Hello everyone, welcome back to another lecture on estimating instantaneous rate of change. So we are discussing different methods of estimating instantaneous rate of change, and the third method we are discussing is called centered interval method. That's the name of this estimation method. So in this method, this is what we do: an interval of the independent variable of the form x in between a minus h and a plus h is selected, where h is a small positive value, and this is used to determine an average rate of change. Basically, that's what we do in this method. There is a word problem here with an example you will understand better. To make a snow person, snow is being rolled into the shape of a sphere. The volume of a sphere is given by the function v of r, just like f of x, equals 4/3 of pi r cubed. That's the formula for the volume of a sphere, actually, where r is the radius in centimeters, and v stands for the volume. Estimate instantaneous rate of change in the volume of the snowball with respect to the radius when r is equal to 5 centimeters. Basically, when the radius is 5 centimeters. So what we should do in this centered interval method, we have to select an interval for the independent variable. In this case, the independent variable will be the radius of the sphere. In this case, it is x. So we have to select an interval. And to do this, I'm going to say r is trapped in between now a plus h, a minus h. What is a here? A is actually 5, because that is where exactly they want us to find the instantaneous rate of change at r equals 5 centimeters. So if a is r, so I'm going to add an increment to that, maybe 1 unit. So 5 plus 1 becomes 6, and then 5 minus 1 becomes 4. So I'm selecting an interval like this, and then I'm going to calculate delta V over delta R, which is actually the volume at 6 minus volume at 4 divided by 6 minus 4. So I can plug in, I can say 4 pi over 3 times 6 cubed minus 4 pi over 3 times 4 cubed divided by 2 is actually that average rate of change. And if you use a calculator, the answer is 318.348. Now, the numerator is volume, so it is measured in cubic centimeters, and the denominator is radius measured in centimeters. So the unit of measurement will be cubic centimeters per centimeter. So this is one answer we end up with. But then you may argue that instead of selecting h to be 1, we could have selected like something smaller, let's say 0.5. So in that case, we would have 5 plus 0.5, which is 5.5, and then 5 minus 0.5, which would be 4.5. So this would be a smaller centered interval, actually, which it makes sense. Then we could find delta V over delta R. This time would be V at 5.5 minus V at 4.5. And same thing in the denominator, 5.5 minus 4.5. And then we would just say 4 pi over 3 times 5.5 cubed minus 4 pi over 3, 4.5 cubed. And perhaps this way we would have a better approximation. 315,206. 206 cubic centimeters per centimeter. So the answers are close, obviously, because both are estimations, but they're not very far from one another. Now, you may still argue that I could have selected a centered interval that was even narrower and smaller. If I had selected an h value which was not 1, which was not 0.5, which was even smaller, let's say it was like very small, such as like 0.01, all right? Then in that case, my centered interval would be 5 plus 0.01, which is 5.01, and 5 minus 0.01, which would be 499 actually. So this is a very, very narrow interval, small interval. So if I would do the calculation for delta V over delta R, so V at 5.01 minus V at 4.99 divided by 5.01 minus 4.99. And if I would do the same math again, so it would be, if I just throw the work, 5.01, and we plug in 4.99 cubed, you need to use a calculator. The denominator would be 0.02 clearly, and this time the answer will be 314.159. So 159. So cubic centimeters per centimeter, 314. So first we got 318, and then 315, and now we got 314. So mind you, if we would find the answer in terms of pi, this would be like 100 pi. Okay, if you would just find the answer in terms of pi, but if you plug in 3.14 for pi, then that would be the approximate answer. So now you have to decide which answer is more accurate. It's needless to say that the smaller the center interval, the smaller the size of the centered interval, then the better the approximation would be. So I would say 315 is a better approximation compared to 318, and 314 is a better approximation compared to the rest. So if I'm supposed to pick an answer, I'm going to go with the last one, and I'm going to say the instantaneous rate of change of volume with respect to radius is 314 point perhaps 1.6, I would say. So instantaneous rate of change of it says volume of the snowball, volume of the snowball, which is a sphere, when r equals 5 centimeters is, I would say, 314.16 cubic centimeters per centimeter. So I would select my last answer. I could have found even more accurate answer, to tell you the truth, if I would select a much narrower centered interval. Like if I would go 5.0001 or 4.999, if that was the very, very small centered interval, then I would get like better accuracy here. I would have a more accurate answer with more accurate digits after decimal point. But we don't need that much accuracy. We're just estimating. So 314.16 is like pretty much good answer. And that will be the rate of change of the volume of the snowball with respect to the radius at that instant when r is equal to 5 centimeters. So as you see, again, we actually calculated an average rate of change, but that average rate of change is found or determined or calculated in between two close points, in between 2 points that are very close to one another. And that's why we call this an estimation. Okay. So this was the third method of estimating instantaneous rate of change. It's called centered interval method, and this was one numerical example for you. I have given you other examples in the past, and to tell you the truth, there is some other methods out there as well, but I think 3 methods of estimation is actually more than enough. You know, we don't need to learn more and more methods of estimating instantaneous rate of change. You can use any of these 3 methods that you have learned so far. If you remember, the first method was called preceding following intervals method. Then we learned the difference quotient method, which was the general method, perhaps the most straightforward method. And then this one is centered interval method. And hopefully, we learned all of them. And now we can do all sorts of word problems. Thank you for your attention and keep practicing.